So these are some of the most missed Quizizz questions heading into tomorrow's test. I just went from a class perspective, which ones did they do the best on, which ones did they do the worst on, and I'm going to do 6 or 7 of the most missed questions. Number 8 was missed a lot. As we look at this problem, hopefully you recognize this is a Usub problem. Because this thing is to the 1/2 power because it's square root, we're going to pick that as our u. So our u is t to the 4th plus 3t. Hopefully you recognize that the derivative of that is going to be 3t to the 4th power plus 3. And you can see, oh, that is not the derivative, just plain. 4t cubed plus 3. You can see hopefully that that's going to cancel right there. du over 4t cubed plus 3 is going to be all equal to dt. We do have bounds, so we're going to go ahead and change those. Upper bound is going to be plug 1 in, I get 4. Lower bound, I'm plugging in 0, I get 0. All right, so we're going to reset up this problem. We're going from 0 to 4, u to the 1/2 power, times, I've got this 4t cubed plus 3 from right here. And then instead of dt, I'm going to plug in what dt is. It's this du over 4t cubed plus 3. Cancel. Integrate. So u to the 1/2 power is going to become u to the 3/2. I add 1 to my exponent. Divide by my new exponent. So if it was 3/2 and I divide by that, it's going to become 2/3. And I'm evaluating that thing from 0 to 4. When I plug in 0, it's going to be nothing. So it's really just 2/3. 4 to the 3/2 power. Hopefully you can do that by now. 4 square rooted is 2. And then 2 cubed is going to be 8. 2/3 times 8. 16/3 is going to be my correct answer. It's C. Usub, make sure you can change your bounds. Number 10, that was quite a missed question here, and it shouldn't be, I hope. Rewrite that thing. This has nothing to do with this chapter. It's just rewriting. That right there is x to the negative 2/3 power. It's negative 2/3 because it's cube rooted. I'm sorry. No, it's not 2/3. I was just playing with you. It's negative 3/2. It's to the 3rd power, and it's square rooted, so it's going to be a 2 on bottom. That's my setup. I'm going to find the antiderivative. So we add 1 to our exponent. So now it's negative 1/2. I divide by my new exponent. So I'm dividing by negative 1/2, which means I'm multiplying by negative 2 plus c. Negative 2x to the negative 1/2 plus c. Answer is D. Number 13, a little bit missed more than it needs to be. Don't miss this one. This is our setup. We're integrating from negative a to a of f of x dx. So we know from 0 to a, it's 10. That means this area is also 10, and I'm integrating starting at negative a. So if I start here, I got 10, and then I got 10 more, and so the answer is 20. Don't think positive and negative just because you're at 0, because you're starting the integration from negative a. All of that area is going to be considered positive. That's where I'm getting positive 20 from. Number 17, we're integrating from 3 to 1 f of x dx. So we're going from 3 to 1. And so this area right here is going to be some positive number. 1, 2, 3 and some change. We'll call it like 3.2. I just made up a number. Okay. That's what that area is, but I don't like that lower bound on bottom. If I changed that and made it from 1 to 3 of f of x dx, we'd have to throw a negative sign in front. We know what this answer is. That's going to be that 3.2. And so my answer needs to be negative, because it'd be like negative 3.2, because we're starting at 3 and we're working back to 1. Just looking at one of these, we did a pretty good job with this, but I want to make sure we understand what's going on. Remember this thing right here, that 1/7, 10 over 3, that is going to find you the average. Well, that's going to find you the average of whatever is right here. So this right here is b prime at t, or in other words, it's the rate of b. It says b of t represents the temperature of the biscuits. So we are finding the average rate of the biscuit temperature. It's kind of a funny question, but that is what we're finding. It is the average rate of the temperature of the biscuits on the time interval from 0 to 3. It's the average of whatever you have in that integral. In this case, it was the rate of the biscuit temperature. That is why the answer is B. I think I got one more for us. Let's do this last one. So this was the most missed in this class. We'll see if it's the most missed for you. What is the derivative of the function? We are integrating. That looks super ugly, but it's 1 to 2x of 6e to the x dx. Don't miss this question. You're finding the derivative of this thing. So if I'm finding the derivative of this integral, we take the upper bound, make sure x is up there, we plug it in, and then you've got to multiply by the derivative of whatever you plugged in. I plugged in a 2x, so the derivative is 2. My answer is B. Nothing too crazy that we missed there. Pretty pleased overall. We had some people doing not great, and I think part of that is just they were some problems that took some time. Hopefully that helps you out. We are testing tomorrow. Make sure you're ready to go.